Hey guys. Welcome to another video of Technonatics. In this video I'm going to show you how I made my project in C# Winforms. This project is a color-coded resistor calculator that could calculate 3 to 6 bands, and now, let me show you the demo of this project. Now, this is the graphical user interface of my project. Inside this form, I used a group box to group some controls, and to make the user interface looks nice and clean. First, when the user wants to choose the type of resistor band to calculate, I used a radio button. Then, when it comes to selecting the colors of the resistor, I used a button. I also added a check image in 12 of these individual buttons, then I set their background color based on the colors of the resistor. Then I put the names of the colors, and make sure that the forecolor is visible with its back color. With the use of picture box, I added 6 images of a down arrow above every color band, that the purpose is to guide the user in selecting these colors. Also, I had set the visible property of these picture box to false, so that there is no selection guide from the start. I also added a label to display a text that guides the user in selecting these color bands. To make this simple color-coded resistor chart, I used a table layout panel to make an alignment of these labels, and these buttons. To make these rows and columns, just highlight the table layout panel, and click this small triangle icon right here, then, select Edit Rows and Columns, then, select this drop down to show the columns and rows. To add some columns and rows, just click the Add button. As you saw, I added 1 column and 12 rows. When I had finished adding all the items, I highlight them all, and set their size type to %. After that, I dragged every individual button inside of these cells, and set their dock property to fill, and I also apply these in every labels inside these other table layout panels. When the user selects one of these colored buttons, then the color will add to the type of resistor band that is selected. For displaying selected colors, I used a panel. I also made a model of resistor using panel, and set the border to fixed 3D. Then I select and right-click, adjust the bring to front and send to back as long as I made this kind of resistor's image here. Also, I added a text box to display the selected colors in text. Down here is the result of calculation. I added some labels, and text boxes for displaying results. These text boxes are read-only, so the user can't modify the results inside. Now let me walk you through to the codes of my project. First, I made a class called Calculate, that is being inherited by the class called Color Control. I also made a class model. 1 is a color value, that is used to store the resistor's color value. Min-max resistance, that is used by one of my methods, to return the calculated minimum and maximum resistance. Result, that is also used by some of my methods, that calculates the resistor as their return type. Now, the user first wants to do, is to choose what type of band needs to calculate. Now, inside one of these radio buttons check change event. This field variable band, which is a character type, is used to store the updates of the selected resistor band. The value of these variables is above this class, and these are the literal number of bands of the resistor. Next, I call the reset method using the instance of the color control class, and this method requires a band as its parameter. Now, let's look what's inside this method. This method uses its band parameter to update this class about the selected resistor band type that is used by some methods inside this class. Inside of this method, I made a local function here called CLR all panel bands that will clear all the colored panels that represents the resistor's colors. Inside those all four types of resistor band models. This local function also sets the index colors of the resistor to default value, which is -1. This index colors is a field variable type integer, which I use to determine the number of colors inside the selected resistor. For setting all the resistor's colors to be empty, I used a query statement, and for each loop. This all panel bands field variable is a two-dimensional array of panels, and inside of these are the panels inside of every band type resistor. This field variable is being initialized by this class constructor's parameter. Now, let's take a deep down look on how I pass this two-dimensional array of panels. From the form1 class, I made field variable called all panel bands. And down here I made an array of panels. These array of panels are being initialized by this initialize color control method, and inside of these are the panels inside of those four band resistor models in our user interface. These array of panels will be put inside of this all panel bands variable, and this all panel bands, which is a two-dimensional array, is required as one of the color control class parameter. And this is used by the query statement. So, what this query statement does is to get the panels inside these all panel bands, then get their individual back color that is not equal to empty. This empty color is a field variable color type. That its color value is equal to control, which stands as an empty color. Then set all of these to be empty, using for each loop. Therefore, this will clear all the colored panels, which represents the resistor's color, inside those four bands. Now, this guide and color filter for all bands method resets the filtering of colored buttons from the start. But for now, I will skip this method and explain this later. Now this enable calculate btn method here sets the enable and disable property of a calculate button using its Boolean parameter. As you see, I set it to false, so that the calculate button is not clickable when resetting the calculation from the start. This clear selected colors text local function clears the list of selected colors that is being added by the add color method, and we talk about that method later. Now, let's go back to the check change event of one of those radio buttons. After calling the reset method, this clear calculation clears the result of the calculation, because every time when the user changes the band, then the result of calculation needs to be empty. Now let's go to the selection of colors. Now, there are total of 12 colored buttons here to select, but some of these colored buttons will not be used every time when the selection of colors changes from one color band to another. Now let's look what's the code behind when clicking one of these buttons. Inside of one of these buttons click event, I called my add color to selected band method, and passing a color button as its parameter. This add color to selected band method determines the selected resistor band, and assigning those selected resistors colors using this add color method. This add color method gets the button's back color, and use as the panel's back color to display selected resistor color. This method requires three parameters: a button's back color which represents the selected resistor's color, an array of panels inside the selected resistor band which I showed you before that it's a resistor model, and the last is the selected type of resistor band. Now let's see what's inside this add color method. This method uses its band parameter to update the field variable band, which is a char type that is being used by this class in some of its methods. To know about the selected resistor, here an int variable called maximum index is used to store the number of resistors color band, -1, to get the maximum index. Then the field variable called index colors, which is an int type. This index colors is a field variable that is used to determine the number of selected colors inside the selected resistor band. This statement here will get execute if the index colors of a selected resistor band reach its maximum value, which means that the selected resistor band is filled up with those selected colors. This method here disables all the colored buttons. That means user cannot select those resistor colors. When we look at this method, this uses a for each loop to get all the 12 colored buttons inside of this colored buttons field variable array, and set it all to be false. This colored buttons field variable array is also being initialized by this class constructor parameter. Now, from the form1 class, I made a colored buttons field variable array, then its value is being set by this initialize color control method. The values are the colored buttons that is used to select the colors of the resistor. Now we go back. After calling this method, this guide label text, which is a label that guides the user in selecting color band, would be empty. And this method here hides the last selection guide, which is a picture of a down arrow based on the last selection of selected resistor band. As you might remember, these pictures are used to guide the user in selecting those resistor colors. What I mean by hiding is, for example, if the selected resistor is a 3 band, then the last guide, which is a down arrow picture, will be on the multiplier. Another example, if it is 4 band, then it will be on the tolerance. And when it is a 6 band, then it will be on the temperature coefficient. Inside of this method, I used an else if statement to determine the selected band, then hides its last guide. Then the last is to enable the calculate button. So we go back here, so when the maximum index color is not reached yet, as you see I have enabled the undo button, so that the user could undo its selected colors if he wants. Then, the panel band parameter, which is an array of panels, these panels are inside of the selected type of resistor, will be filled up with selected colors every time when the user selects. Then this local function here called add colors to text box is used to displays the selected colors in text. This selected color lst is a field variable type list that is used to store the selected color's name. Using the join method, I was able to separate the list using space and set this as selected colors text box text. Then this last method called guide and color filter for all bands method is used to filter some of the colored buttons based on the resistor's color band, and at the same time, it guides the user in selecting those colors every time when the user selects a color band from one to another. This method is a pretty long journey to explain, but I will try my best. Inside this method, I used a band field variable and using switch case statement to determine the selected resistor's band value. In every case of a particular selected band, I called this method guide and color filter, then underscore the band resistor type. I put the band type because the guide and color filtering is exclusively on that particular band. These are void methods, and inside of these, I used an index color field variable to determine the index colors of the selected resistor. So, as you see, this is 3-band resistor, and when its index color is not yet being incremented, so that means user first to start to select those colors. Then this enable digit colored btns method will filter to show only the digit colors of the resistor. Inside this enable digit colored btns method, I used a query statement to select only those colors of the digits of the resistor. As you've noticed that these colors are the 12 colored buttons that represents the resistor's color. This query says, select a button that its back color is not equal to gold and silver, then enable these colors. Then, this enable this colored btns method is used to enable those selected colored buttons from the query. As we go to the peak definition of this method needs an enumerable type as its parameter, which we passed our query statement. Then, this uses a for each loop to get those all 12 individual colored buttons, and using an else if statement to determine if the selected buttons contains one of these colored buttons. Then, this will enable the buttons, else if not, then they are going to be disabled. Now we'll go back to our guide and color filter method. After calling this enable digit colored BTNS method to filter the resistor's digit colors, then, this guide for first digit method will be called. Now, let's look what's inside this method. So, this method is used to set the visibility of the first digit guide picture, which is a down arrow image, and also the guide label text will show the text to the user. To select the first digit color. When we look at inside of this show guide img method, this method requires a picture box to be visible as its parameter to get the guide image, which is a down arrow. That is used to guide the user from selecting those color bands below. And again, using for each loop, I was able to get those pictures inside of this guide images field variable array, which contains those 6 picture box. This guide images field variable array is also being initialized by this class constructor's parameter. As you see, inside the for each loop, I made a Boolean variable called showSelectedImage to determine whether one of those images is equal to the image to be visible. Then using ternary conditional operator to know that if the showSelectedImage is equal to true, then the image to be visible will set its visible property to true. Otherwise false. So now, let's go back to our guide and color filter method. After when the user selects the first color, which is for first digit of this 3-band resistor, then the selection for the second color will be filtered, and because this second color is also a selection of a digit color, then, I called again this enable digit colored BTNS method here, and after that, the guide for the selection of color changes every time when the index color change. Then the last is this index 1, which is the maximum selected color index of this 3-band resistor, so, it will filter to only show the colors of the multiplier, using this method. Then the guide image of the multiplier will only be visible. This is the same scenarios that is also applied in one of these guide and color filter method for the other resistor bands. So that's it for our add color method. Now, how about on how to undo those selected colors inside the resistor? Now, we go back to the form, and double-click this undo button, so that we can see what's the code behind. Inside this undo button's click event, is this undo color from selected band method. Again, inside of this I used a switch case statement here, that also determines the selected resistor band, and execute this undo color method. This method requires 2 parameters, an array of panels inside of a band type resistor that displays the colors, and the type of resistor band selected by the user, which is a char data type. So now, let's see what's inside of this undo color method. Inside this method uses its band parameter, that also updates the field variable band of a color control class. Then, unlike for the add color method, the index colors is being increment, now this time, index colors is being decrement. Now, if the index colors is less than or equal to -1, then index colors will stay to its minimum value. Then, when it is minimum value, so there are no colors inside the resistor, so undo button will be disabled. I also called the enable calculate btn method, and pass a boolean value of false, to set the calculate button's enable property to false, that means that user can't calculate the resistor, when colors had to be undo. Then, also the panel band parameter, which is an array of panels inside the selected type of resistor band, will be set to empty color, from user's recent selected color. Going to its started selected color, every time when the index color variable decrements. Then, this local function called undo color frm textbox method, is used to undo the displayed selected colors in text, inside the selected colors text box. Inside this local function, I used a remove at method, to remove the index of selected colors inside this list field variable. Then again, using the join method, to join this space to separate those lists of remaining colors, and that list would be displayed to this text box. Then, I called again the guide and color filter for all bands method, to also filter the selection of resistor colors, and to guide the user from its last selection. Now the final job of this application, is to calculate the selected resistor's colors using the calculate button. Inside this calculate button's click event, is only one method, a display calculation. Inside this method has a result type variable, and it is being initialized by this display calculation local function. This local function requires a color band as its parameter, which is an array of panels, inside of the user's selected band resistor, and it used by this calculate band method. That returns a result type. As we go back, this result type consists of these following variables, that is used to return the calculation of color code resistor. Now let's look at what's inside this calculate band method. Now, I made an initialization value of result here, that sets its public variables to -1 as its default or empty value. Next, I made a 6 objects variables of panel, to get every possible elements of this resistor colors, that represents the color band by determining the selected type of resistor band of the user's selected resistor. Using the switch case statement, to determine the selected type of resistor band, I was able to correctly initialize these 6 objects variables of panel. From the elements inside of this selected resistor's color. These 6 object variables of panel will completely use, when it's a 6-band resistor, otherwise, some of them were not get initialized. For example, this 3-band resistor here, initializes only the color bands he needs, the first second digit and its multiplier, the rest will not be used, and that also happens in 2 other bands here. And as you noticed, I already initialized the first and second digit color above here, because, this first and second digit color will be used, no matter what type of resistor band is selected. This calculate selected band, are the 4 overload methods, that returns a result type as their return value. These methods, calculate 3 to 6 bands of resistors, and these panels as its parameter, which represents the colors of the resistor. Now let's look at these 4 calculate selected band methods. Inside these 4 overload methods I made some variables. One of them is the concat digit, which is a string type, that is used to store the concatenated digit values from the resistor's colors. Using my getColorValue method, I was able to get the values of the color, which might contain the digit, multiplier, tolerance, and temperature coefficient. To understand how this getColorValue method works, let's take a look what's its definition. This getColorValue method uses the color value type as its return type. Now, this color value type has some parameter on its constructor that contains the following resistor's color possible values. And when we look at inside of this getColorValue method, as you see, these are the initializations of resistor's colors value. As you notice, I put some -1 in some of the resistor's colors value that indicates no value to return. After giving values to those colors, I made another local variable of color values and use this to assign the return value of this method. Using the switch case statement, I was able to use the parameter of this method, that represents one of the resistor's color, which is a panel, and get its back color name to determine the color. Then assigning its return value, else the default values would be all negatives. Now we'll go back to our calculate selected band, overload methods. This calculate band right here calculates the 3-color band resistor, and I only get the first and second digit color. After that, this another field variable digit, which is an integer type, stores the converted concat digits from string to integer. Then this resistance local variable, which is a double type, stores the calculated resistance, by multiplying the digits to the color value of multiplier. Also, to get the minimum and maximum resistance, I used method called getMinMaxResistance, and these are another 2 overload methods. One is for the 3-band resistor. Because of its default tolerance value of 20%, we don't need the tolerance color as its parameter, and for the other 4 to 6 band resistor, that needs a tolerance color to get the value. Then using this formula, I was able to get the result of minimum and maximum resistance. So now let's go back to our calculate selected band method. Then after all of this, the result value will return. Now this kind of statement here also applies in one of the other overload methods here. The difference between them is the calculations of numbers of resistors color band. So now that I've finished to discuss what's the code behind these 4 calculate selected band overload methods here, then let's go back to the calculate band method. Now, let's go back to the display calculation local function, inside the display calculation method, in the form1 class. Now, this calculate band method, which returns a result type, and some of its values like resistance, minimum and maximum resistance, needs to be converted to a scale of number of resistance values, or measurement units, like kilo ohm for thousands, mega ohm for millions and so on. So, because of that, I made a local function called format to scale of number, that solves that problem. Inside of this format to scale of number local function, I made some variables, and these are kilo, mega, giga, tera, that corresponds to their measurement value. This exceeds value, which I used as the basis, of the biggest impossible calculated value of the resistor. But the maximum resistor's possible value, based on picking the biggest value of the color in the chart, would be this value. But instead, I added this 10 tera ohm, as the value of exceed variable, but that's not a problem, because the values of resistors colors are fixed, and the user cannot change. Because they pick the colors with value, and it would be impossible to get some out of range exception here. Then, I made some Boolean variables, to store the true or false, if the range of the resistance, is in that particular scale of number or measurement unit. I also made a custom numeric format, and store it inside the string variable, but I'll skip this for now. So here, I used a ternary conditional operator. This statement here means, if the resistance is in kilo ohm, then divide this resistance in kilo, which has a value of 1000. Then, using toString method, by passing the custom number format variable, as its parameter to convert this into a custom numeric format. This custom numeric format, formats the value of kilo ohm, of at least 3 decimals if it has. After that, I added this shortcut kilo ohm at the end. And the same as, goes apply here, for the mega, giga and tera. Then, the last one here, if none of the above, is in range of scaling of resistance value, then this would go to the value of resistance, ranging from 1 to 999, so I added only the omega sign after the value. Then returning the result, and displaying inside these text box. And for the resistance here, with the use of string interpolation, to display the result of resistance, that includes this plus or minus sign for its tolerance value and percent sign. Then we go back to the statement above. So, with the help of the switch case statement, I was able to determine the selected band, so that I could properly execute this display calculation local function, that displays the result of color-coded resistor calculations. And for the 6-band resistor, this temperature coefficient, needs to display in the results of the calculations, and using the string interpolation again, to display the value of temperature coefficient with the ppm degrees Celsius. So guys, now that I had explained some of the main functions of my project, so you can download the source code of this application if you want. I put a download link in the description of this video, and please don't forget to subscribe to my channel. Thank you guys for watching, and see you on the next video.